Hello, we want to take a look at the ways that exponential growth or exponential equations and functions can help us through exponential growth and decay. The mathematical model for exponential growth or decay is given by A naught times e to the kt. Now, A naught is your original amount, the amount you started with. T is time, of course, and K is called the growing entity. And it is a constant, a number, and we'll look at how we find that here shortly. Exponential growth goes up, exponential decay goes down. Example 1. In 2000, the population of Africa was 807 million, and by 2011 it had grown to 1,052 million. Use the exponential growth model, in which t is the number of years after 2000, to find the exponential growth function that models the data. And then it has a question for us. So when we're doing these problems, unless it goes ahead and gives us the function, the first thing we have to do is find t. Now what we've got here is we've already got two pieces of information. We've got that in 2000, the population was 807 million. In 2011, the population was 1,052 million. And so since we've got these two pieces of information, then we can use those to help us find K. We'll use our function A equals A naught times e to the kt. So A naught is the original amount, 807. A is the amount that we have now, 1,052. And T is the amount of years from where we started to where we are now. So 2011 minus 2,000. T is 11. And now we just solve this for K. So start by dividing both sides by 807, and I'm going to keep this as a fraction to prevent rounding error. And then how do we get rid of an e? We natural log both sides. So the natural log takes away the e, and we're left with 11k is equal to 1,052 over 807. No, that's the natural log of that. Okay, and so that means that k is the natural log of 1,052 over 807 divided by 11. That's 11 here. We divided both sides by 11. And so that gives us K to be approximately 0.024. Now with that information, we can write our equation. A equals our initial amount, 807, times E, to the K, which is 0.024 times T. So T is our unknown, and A is our unknown. If we plug in for one, we can find the other. And so with this equation, with this function, we're asked a question. It says, by which year will Africa's population reach 200 or 2,000 million or 2 billion? So what we're going to do is we're plugging in 2,000 for A. And this time we're solving for T because we want to know how many years since 2000, the year 2000, was there before we had 2 billion people in Africa. And so we go through basically the same process. So divide by 807. Natural log both sides. That gets rid of the E. So we have 0.024t is equal to the natural log of 2,000 over 807. Divide both sides by 0.024, and we have natural log of 2,000 divided by 807 divided by, all that divided by 0.024. And that gives us about 38 years. So what year was the population 2 billion? We would take the year 2000 and add 38, and it would be the year 2038 that we predict that there will be 2,000 or 2 billion people in Africa. Oh, it's snowing again. If they were big enough flakes, I'd take a picture for you. But I don't think you could see them. Okay, on to example 2. A colony of bacteria increases according to the law of uninhibited growth, which is basically saying that there is no limit to the growth. If N is the number of cells and T is the time in hours, express N as a function of T. So we've got our function A equals A naught e to the kt. And we want to express it with N as a function of T. It's as simple as this. Instead of A naught, we have N naught. Because instead of expressing it as a function of A, we're doing it as a function of N. And actually, we'll go ahead and change A to N there too. Okay? If the number of bacteria doubles in 5 hours, find the function that gives the number of cells in the culture. So we have N equals N naught e to the kt. And we know that it doubles in 5 hours. So we know that N in 5 hours would be 2 times N naught. So, N for N, we're going to plug 2 times N naught. Notice that enables the N naughts to go away. If not, we'd have a problem. So, we have 2 equals e to the kt. To get rid of the e, natural log both sides. And we have t would be 5 because of 5 hours. Okay, so we have 5k is equal to the natural log of 2. Or k is the natural log of 2 divided by 5, which is approximately 0.13863. So the function would be n equals n naught times e to the 0.13863 t. Next question. How long will it take for the population to double a second time? Oh, I think I skipped one. How long will it take for the size of the colony to triple? So we're just looking at part C here. Okay? So to triple, we would need 3 n naught. And we would solve for t. So the n naughts go away, and we have 3 equals e to the 0.13863 t. Natural log both sides. So that 0.13863 t is equal to the natural log of 3. So t is the natural log of 3 divided by 0.13863. Approximately 7.925 hours. And last, how long will it take for the population to double a second time? Or increase by 4 times? Well, if we look back, it's told us that it doubles in 5 hours. So guess how long it's going to take it to double again? Another 5 hours. So just 10 hours. Didn't have to go through a whole lot of work there. Okay. Last example, it says the half-life of strontium, I don't know if I said that right, but we'll go with that, is 28 years, meaning that after 28 years, a given amount of the substance will have decayed to half the original amount. Find the exponential decay model for strontium-90. If there are originally, well, we'll look at that in a minute. So let's start with finding the model. So we'll start with A equals A naught times E to the KT. And it says the half-life. So what that means is, like in the last problem we were doubling or tripling, this time we're halving or having the initial amount. And that initial amount is halved in 28 years. So T is 28. Just like before, A naught will go away. To get rid of the E, we natural log both sides. So K is the natural log of 1/2 divided by 28. approximately negative 0.0248. So the function would be A equals whatever A naught is times e to the negative 0.0248 t. And then it asks us a question. How long will it take for the strontium-90 to decay to a level of 10 grams if there are originally 60 grams? So we want to decay to 10, and we started with 60. Get that out of the way a little bit. Okay, so divide both sides by 60. We'll have 1/6 equals e to the negative 0.0248 t. Natural log both sides again. And negative 0.0248 t is equal to the natural log of 1/6. So t is equal to the natural log of 1/6 divided by negative 0.0248. Approximately 72 years. So this concludes the first section on modeling exponential functions and exponential growth and decay.